Okay, in this video, let's talk about section 13.5, Binomial Theorem. Binomial Theorem. So first, let's talk about the combination numbers. Evaluate. Here they read it like n taken j at a time, or you can say it n choose j. Okay, so evaluate this symbol. You have the parentheses on top. You write n, the bottom you write j, but it's not a fraction. It's just a symbol. Okay, so you can read it as a n taken j at a time. N taken j. Or you say n choose k. N choose j, here's j. Okay, so what is the definition of this symbol? Definition of the symbol says if j and n are integers with 0 less than or equal to j less than or equal to n, then this n choose j is defined as n choose j is equal to n factorial over j factorial times n minus j factorial. So it's a ratio of 3 factorials. So this is the definition. First, do you still remember what factorial means? N factorial means 1 times 2 times 3 times 4 times 5 up to n. The product of the first n integers. The product of the first n integers. So this is a factorial. Okay? And n choose j, n taken j at a time, is defined to be this by this formula. So first, let's see the example. We try to evaluate. If we want to evaluate 3 choose 1, it means you have 3 factorial over 1 factorial over 3 minus 1 factorial. So 3 factorial is 3 times 2 times 1. 1 factorial is 1. 3 minus 1 is 2. 2 factorial is 2 times 1. In the evaluation of this n taken j at a time, you should do a lot of cancellation. So 1 you don't worry about it. 2 cancel. 1 cancel. This 1 you don't worry about. So the value is actually 3. This value must be an integer. If you get some computation you got wrong, that's just because you you do some computation wrong. It has to be an integer. Okay. So another example, for example, 4 choose 2. 4 choose 2 is 4 factorial over 2 factorial, 4 minus 2 factorial. 4 factorial, 4, 3, 2, 1, product. 2 factorial, 2 times 1. 2 factorial, 2 times 1. 4 minus 2 is 2, so it's 2 factorial times 2 factorial. So we cancel this, 1 you cancel it. The numerator is 3 times 4, 12. 12 over 2, 6. 12 over 2 is 6. And C, 8 choose 7. 8 choose 7. Okay, 8 choose 7 is 8 factorial over 7 factorial and 8 minus 7 factorial. 8 factorials, 8, 7, 6, 5, 4, 3, 2, 1, product. 7 factorial, 7, 6, 5, 4, 3, 2, 1. 8 minus 7 is 1. 1 factorial is 1. So you will see that most of the term will be cancelled, so it's equal to 8. Okay, so this is our n choose k, n choose j, or the n taken j at a time. All right. This number will be very huge if you have a very large j, a large n. For example, in the textbook they provide an example: 65 choose 15. 65 choose 15. Now you have a real computation. It's possibly like this. You will have a 65 factorial over 15 factorial, and 65 minus 15 factorial. So it's a 65 factorial over 15 factorial. This is a 40 factorial. Okay, so 40 factorial. You see here, when you write this as 65, 64, do the long product. Here is a 15 times a 14 times 1. Here you have a 40 times 39 times 1. And I'm going to cancel this long tail. This 40 cancel with the 40 from the top. Okay, so what do you get? You will get a 65 times 64, 63, times up to 41. 40 is cancelled from top and bottom. And the bottom, you will have 15 times 14 times 13 times 1. 1 you don't worry about. And this is a very huge number. Trust me, it's a very, very huge number. The textbook provide approximation. It's approximately 2.073746998 times 10 to 14. Times 10 to 14. This is a huge number, but this is an integer. Even though when we do the approximation, we write this way, but this is integer. It's a huge integer. Okay? So that's a n choose k, n taken k at a time. Okay, so that's a symbol. For this symbol, we have some common used numbers. For example, n choose 0. For whatever n, if you have n choose 0, let's check it. We know that 0 factorial is 1. By definition, 0 factorial is 1. We just defined it this way. And it's n factorial over n minus 0 is n. It's equal to 1. So n choose 0 is always 1. N choose 1. N choose 1, you see that you cancel most of the term except the first term. N choose 1 is n. N choose 1 is n. And n choose n minus 1. N minus n minus 1 is 1 factorial. That's exactly this one. It's also equal to n. N choose n minus 1 is also equal to n. All right? And n choose n. N choose n is you see, it's symmetric to this case. It's equal to 1. Okay, so those 4 quantities, 4 special n choose k are required to be memorized. They are commonly used. So why do we always say n choose k, n choose k? So basically, this number represents the following stuff. Assume you have, for example, let's pick up n equal to 4. You have 4 balls with numbers. You have 4 balls with numbers. They're all the same, except the number. Same color, same size, but different number. And you just pick up 2 balls. For example, choose 2 balls. If you choose 2 balls, how many different choices? How many different choices? What do you mean the different choices? You may choose 1 and 2. This is a 1 choice. You choose 2 balls. Or you choose 1 and 3, and 1 and 4. So they are considered as 3 different choices. Or you will choose 2 and 3. Oh, 1 and 2, 2 and 1 are the same. We do not distinguish the orders. So we just choose 2 of them. Okay? And 2 over 3, 2 over 4. and 3 and 4. So there are 6 different choices. From 4 balls, you choose 2. 4, choose 2. So if you compute 4, choose 2, it's equal to 6. So actually this number means how many different choices for you to choose from n balls, from 4 balls, choose 2 balls. Okay, so this is this has such real meaning, practical meaning. So n choose k, n ball choose 2 ball, and if we understand this process, we will see n choose 0. From 4 balls, you do not choose any ball, then there's only one way, right? You choose nothing. If from 4 balls you choose 1 ball, so you can choose 1, or you can choose 2, you can choose 3, or you can choose 4. So you just have 4 ways. If you have n balls, you choose 1, you have n way. If you have n balls, you choose n minus 1. You choose n minus 1. Basically, it's equivalent to say you choose to leave 1 ball behind, right? You choose to leave 1 ball. It's equivalent to say you choose n minus 1 ball. So that's why it is also equal to n, because you can only possible leave first ball there, or leave the second ball there, or leave ball 3 there, or leave ball 4 there. So there are only 4 choices. If you choose n means you take all balls. There's only one way, right? So this is called the combination, combinatorics. This is called combinatorics. All right. Next, we have so many numbers n choose k. For those numbers, let's build them in a nice way. We have the following tower. We put 0 choose 0 here, and then we put 1 choose 0, and 1 choose 1, and we put 2 choose 0, 2 choose 1, and 2 choose 2. Like a pyramid, triangle. And 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. And 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. And you can continue this without end. Continue without end. And then you can evaluate all of them. I'm going to reproduce it here. The top, the vertex, for whatever n, you put 0 on the bottom, the value is 1. Okay, and 1 choose 0, 1 choose 0 is also 1. 1 choose 1, n choose n is a 1. 2 choose 0, 2 choose 0 is a 1. 2 choose 1, n choose 1 is n, so it's 2. 2 choose 2, 2 choose 2 is a 1. Okay, and then you see here, n choose 0, 3 choose 0 is a 1. 3 choose 1 is equal to 3. So from number 3, you will check all those 4 cases. And 3 choose 2 means that 3 choose m choose n minus 1 is equal to n. 3 choose 3 is a 1. And if you exam 4, you actually this one, this one, this one, this one. First, the second, the third, and fourth, they are from the 4 properties. Only the middle, 4 choose 2. 4 choose 2, we did the computation, it's a 6. Okay? And you can continue this. Well, you continue this, you will get the, this is a 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 4, 5 choose 5. And you can also even continue this. This is called the Pascal Triangle. It's called the Pascal Triangle. And how do we predict the next row? The pattern is the following. If you get 2 adjacent positions from the preceding row, you add them, it will give you the the corresponding row, corresponding value in the next row. You see, 4 plus 6 is 10, so you write it below this midpoint. You got 10. 6 plus 4 is 10, so this is 10. 4 plus 1 is 5. This is 5. 1. The two sides are always 1. So this left side is always 1. Right side is always 1. 1 plus 4 is 5. You see, 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. 1 plus 2 is 3. 2 plus 1 is 3. 1 plus 1 is 2. So if you know this pattern, you can predict the next row. The first is always 1. Then 1 plus 5, you got 6. 5 plus 10, you got 15. 10 plus 10, you got 20. 10 plus 5, you have 15. 5 plus 1, you got 6. And the last one is 1. And this row corresponds to, this is a 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, and 6 choose 6. You can verify that they are the right one. And you can continue this. You get a 1. 1 plus 6 is 7. 6 plus 15 is a 21. 15 plus 20 is a 35. Here you have 35. You have a 21. You have a 7. You have a 1. This is the row for the 7, number 7. Okay? So the Pascal triangle is an automatic process. You get the first row, you get you can write down the second row. You get the second row, you can write down the third row. Okay? It's like the mathematical induction. You do it row by row. You cannot skip, jump. All right? So this is the number we need, the n choose k number. Right, now after n choose k number, let's say the binomial theorem. The binomial theorem is the following thing. I want to expand this x plus a to nth power. I want to expand it. How do I expand it? We do the following thing. The first term is x to n, and it has a coefficient n choose 0. It has a coefficient n choose 0. And second term is n choose 1 times a x to n minus 1. And this time you add a factor a, but you drop a factor of x. And then n choose 2, you continue increase the factor 2 and drop the factor x. Factor a, you increase the factor a, drop the factor x. And n choose 3 is a cubed x to n minus 3. So you see here, the x has exponent decreases, and a has exponent increase. Here's 2, here's minus 2, here 3 is minus 3. And this j depend on this the degree of the exponent of a. And you continue this until you have n choose n minus 1. Then this place you have a to n minus 1. Then x, you only have 1. And the next n choose n, you will have all a to n, but without x. All x disappear. And this is called the binomial theorem. This is so-called binomial theorem. And write it in the sigma notation. The sigma is this way. J is from 0 to n. You always have n choose j. A, it has power j. X, it has power n minus j. You let j be 1, 2, 3, up to n. It's a finite sigma, finite sum. And here, this n choose j, because it is the coefficient of each term, is called the binomial coefficient. There are many binomial coefficients. Okay, that's another name. All right, so this is a binomial theorem. We are going to see how do we use this theorem to expand it, to expand this power. Okay. See example. Use the binomial theorem to expand x plus 2 to 5th power. X plus 2 to 5th power. Okay, now let's try it. Here, a is equal to 2. That's the only thing. Okay, so it's n choose 0, x to 5, n choose 1, you have a 2, x to 4, n choose 2, x squared, x cubed, a2 squared, x cubed, n choose 3, 2 cubed, x squared, n choose 4, 2 to 4, x, n choose 5, 2 to 5, no x. Okay, at all the places is addition. All the places from the formula is addition. And now let's try to, not n, 5, 5, 5, 5. It's always 5, my bad. It's always 5. This n is a power 5. So 5. Okay, so from the triangle, Pascal's triangle, from the Pascal's triangle, this is a Pascal's triangle for n equal to 5. So 5, 0 is a 1. 5, 1 is 5. So 5 times 2, x to 4. 5, 2 is 10. 10 times 2 squared is 4. 5, 3 is another 10. 10 times 2 cubed is 8. 5, 4 is 5. 5 choose 4 is 5. 2 to 4 is 16. 5 to 5 is 1. 2 to 5 is 32. Okay, and if we simplify it, 2 times 5 is 10x to 4 plus 40x cubed plus 80x squared plus this is also 80x plus 32. Okay, so this is an expansion by the binomial theorem. It's an expansion by the binomial theorem. All right. Let's continue this exercise. Expand 2y minus 3 to 4 using the binomial theorem. The binomial theorem, be careful, it's always x plus a to nth power. Here, 2y minus 3, it means 2y plus negative 3. So a is negative 3. By the binomial theorem, you have a 4 choose 0. Then the first x is 2y, 2y to 4th power. And the 4 choose 1, you get a negative 3 and the 2y cubed. And the 4 choose 2, you get a negative 3 squared, 2y squared. And 4 choose 3, you get a negative 3 cubed times 2y. And the 4 choose 4, is negative 3 to 4th power, and there's no 2y. So 4, 3, 2, 1, 0, and then 0, 1, 2, 3, 4. I'm talking about the exponents of x and a. Okay, now for the 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, you just go back to the Pascal's triangle, you figure out it is a 1, 4, 6, 4, 1. Okay, so this is a 1, you don't drop it, don't copy it. 2y to 4, it's a 2 to 4, y to 4. This part is a 4. 4 choose 1 is 4 times negative 3. And this is a 2 cubed y cubed. And 4 choose 2 is a 6. 6 times negative 3 squared is 9. Then you have 2 squared y squared. And plus 4 choose 3 is a 4. Negative 3 cubed is negative 27. And times 2y. 4 choose 4 is a 1. Negative 3 cubed is 81. Okay? And then you are going to compute those numbers. And 2 to 4 is a 16 y to 4. And here is a minus. See, it's a minus. It's a minus, what is it? It's a minus 96 y cubed. Okay, it's a 12 times 8. 4 times 3 is 12. 12 times 8 is 96. And plus, so this is a 6 times of 9 is a 54. 54 times 4. 54 is a 216 y squared. And this becomes minus. It's a 27 times 8. 27 times 8 is also 216y and plus 81. Alright, so this is an expansion. And this example tells us the binomial theorem can also be applied to the difference. If you consider difference as a sum with a negative number, be careful about this. If you have a difference, you will see the sign is always alternating, plus minus, plus minus, plus minus. If it's a sum, then the after expansion is always addition, but if it's a difference, it is alternating. All right. Next example. We'll have more examples. Find the coefficient of y to 8 in the expansion of 2y plus 3 to 10th power. Okay, we don't find the complete expansion. We only want to know the coefficient of y to 8. Okay, so the first one is 10 choose 0. Then you will have 2y to 10. And next, you will have 2y to 9. And then you have 2y to 8. Okay, only in this term, you will have y to 8. Other term, this has y to 10, y to 9, y to 8, y to 7, up, and y to 6, 5, 4, 3, 2, 1, 0, nothing. So only this term will give you the the answer to your question. Okay, so when you get 2y to 8, what's the rest of the part? The rest of the part, here's 8, then you have 3 squared. 2 plus 8 is 10. And 3 is 2, so you choose 10, you write the coefficient 10 choose 2. All right, so here you determine 8, then from 8 you get the correct exponent for the second term, for the other term. So 3 squared. This 2 means you will have this binomial coefficient 10 choose 2. Okay, so this is 10 choose 2, 3 squared, 2y to 8th power. 2y to 8th power. This term will give you the y to 8. Okay, now let's 10 choose 2. 10 choose 2. Let's try to compute. Three squared is 9. 2y to 8th power is 2 to 8 times y to 8. Okay, let's continue the simplification. So here you have a 10 times 9 times 8. Here you have 2, and this is 8. 10 minus 2 is 8. 8 factorial is 8, 7, and stuff. and times 9 times 2 to 8, and y to 8. Okay, this 8, 7 stuff is cancelled with 8, 7 stuff. And this 2 cancelled with this 10, you got 5. 5 times 9 is 45. And times 9 times 2 to 8. What is 2 to 8? Just do it time by time. So it's 256. 2 to 8, you just do it one by one, you will get 256. And it is equal to 45 times 9 times 256. This 9 is here. 45 comes from this combination coefficient. All right, so you really do the computation. I can do it here. So the product, the first two is a 405, and 405 times 256. It's what is it? It's 103,680. Yeah, I'm right. Okay, so the coefficient is 103,680. This is the coefficient. All right. Let's see another example. Find the sixth term in the expansion of x plus 2 to 9th power. Sixth term, what is the sixth term? First term, it starts from 0. 10 choose 0. Here, 9 choose 0. And second term, 9 choose 1. So sixth term will be 9 choose 5. Okay, so there's a one number shift. So first term, 9 choose 0. Second term, 9 choose 1. Sixth term is 9 choose 5. So the sixth term is 9 choose 5. And then you have 2 to 5, x to 4. This 5 give you the exponent of the second factor, second summand. And x to the power of 9 minus 5 is 4. Okay, so this is the sixth term. You don't have to write everything. You just check which coefficient you have here. From the coefficient, you can determine the rest of the terms. Okay. Okay, so let's check. 9 choose 5. It's a 9 factorial over 5 factorial over 9 minus 5 factorial. And 2 to 5, if you do the computation, it's a 32 x to 4. That's 9, 8, 7, 6, 5. 5 factorial, 5, 4 stuff. 9 minus 5 is a 4. 4 factorial, 4, 3, 2, 1. Okay, 5 factorial cancel with this 5. The numerator becomes a 9, 8, 7, 6. Denominator 4, 3, 2 times 32x to 4. Okay, so 3 times 2 is 6. 6 cancel. 4, 8 cancel with there's a 2. 7 times 9 is a 63. 63 times 2 is 126 times 32x to 4. Okay, let's try. 126 times the 32. So it's 2, 5, 6, 8, 7, and 3. So it's 6, 4036. Oh. Huh? Oh, my bad. Here's 2. Here's 2. So 4032. Now it's correct. 4032 x to 4th power. So this is the 6th term. The 6th term. Okay? This is the 6th term. Okay. Next one. Let's make some observation. The Pascal's triangle. Let's talk about Pascal's triangle. The Pascal's triangle, remember that we observe you have two numbers, two adjacent numbers. You add them, it will give you the number in the next row. It will give you the number in the next row. And this corresponds to what? You see, assume this is a number 4 is a row n. Row n, you have n choose something, n choose something. This is j. This position is j. This position, the next will be j plus 1. Right? You see, j, j plus 1, 4 and 6. The second and third, j's position, j plus 1's position. You add them, it will, the sum will give you the number in the next row. What is the next row? Next row, it corresponds to n plus 1. This position, you see, this is j. This is j plus 1, 3, 2. And here is also the position 3. So it corresponds to the next, the next position. So it's j's position, j plus 1's position. This is also the j plus 1's position. So this is the theorem, the additivity. This theorem is literally the observation we had when we studied the Pascal's triangle. Okay? So you start from one row, you add two adjacent numbers, it gives you the number in the next row. So you add two numbers, adjacent you have jj plus 1. Same row means you have nth row. And the sum will be in the next row, n plus 1. And the position is the same position of the j plus 1's position. All right? So this is the theorem. In the textbook, we see the algebraic computation. They literally start from the n choose j plus n choose j plus 1, and you compute it, n factorial, and j factorial, n minus j minus 1 n minus j factorial, and plus here n factorial, j plus 1 factorial, n minus j minus 1 factorial. They start from here, you get the, eventually you get the step, this right side, n plus 1 factorial, and j plus 1 factorial, and n minus j factorial, and their steps. And you should do this practice by yourself. In the textbook, they use j minus 1 and the j. In our case, we use j and the j plus 1. Either way, I just want to tell you they are adjacent. Okay? So you do the same process, similar process like the like what they did in the textbook. Try to see if you can get this part. If you couldn't, I will give you the complete computation tomorrow. Okay? I will take the do the computation, take a photo, and send everyone. Just try to do it by yourself, and this computation will help you to understand the factorial operations. Okay? Okay. We finished the section 13.5 binomial theorem. Do your exercise. Send me email if you have questions. Thank you.